This is Breaking Down Security, and I am Brian Brake. Welcome back, listener. This is Brian and Mr. Betcher for Breaking Down Security.
Hey, Brian. It's like It's been a whole week since I talked to you.
Oh, yeah. How was your week?
So far, so good.
Yeah. Well, we're laughing because we just did yesterday's podcast with the business justifications, and now we're doing our other podcast today. So, yeah, we had some scheduling conflicts with this one. So, not our guest's fault, of course. It was actually the help. The help couldn't show up on time. So, yeah. So, yeah. So, we're having a contest for DerbyCon, as you've heard from all of our podcasts up to this point. We're doing a capture the flag. So, check those out. I think it's our May 1st podcast, the 2016-17 episode where we talked about it first off. Get involved with that. It's not like a typical one where it's like a race to the end. We're up to like stage 3 now, so you can still get involved if you want to do that. And we're also doing a raffle for another ticket. To get involved with that, if you want to donate increments of $50 to get chances to win, you donate increments of $50 to Hackers for Charity. Or you can support us on Patreon at the $20 level, and that'll give you an entry to make it in. So, we've got a couple people now with 3 or 4 entries to the drawing to get a free ticket to DerbyCon. So, me and Mr. Betcher will be there, and our guest this week will be there as well, who we will be introducing here right now. As a matter of fact, I would like to introduce Dr. Matt Miller. It is Doctor,
Howdy.
Right? Doctor?
It is Doctor, yes.
Yeah? Right
I
on?
did earn that.
Very nice, very nice. So, Matt, maybe, I'm sorry, Dr. Miller, would you please, or what would you prefer, just Doctor or Mr. or what?
You can call me Matt, that's fine.
Ooh! Okay, so Matt, if you could tell us a little bit about yourself, how you got to where you're at right now.
Yeah, so I started in grad school, or in undergraduate. I went to University of Nebraska at Kearney. Mm-hmm. Went there during probably the worst time to go computer science. The .com bust I was in there. Graduated 2003, got married in 2003, and then went to grad school for 8 years. So I got my master's and my PhD at Kansas State University. And while I was doing that, I was working part-time at a small company, did about $1 million a month in shower doors and laboratories, and sort of cut my teeth in programming. I'd done it before, but you get to the real world, and that's where the rubber meets the road. So, and then for 3 years I went to Dakota State University in South Dakota, and I started working on security. So I got into reverse engineering up there because that was what they needed for their cybersecurity, was somebody in reverse engineering. So I went and got trained in that. So all 3 of my degrees are in computer science, and so I think that's a really good background for cybersecurity, to understand how the machine works and how you can do that. So
very cool. So I don't have an Uber degree. Mr. Betcher, and you went to a more traditional college than I did. I went to University of Phoenix. What? Home of the Phoenixes. We got a stadium. We're still trying to build a team. So, so the discussion we wanted to have with you this week was, we keep hearing on Twitter, we keep seeing how people are kind of polarized on the fact that, certifications like CISP or, CEH, or those are not as good as a degree. Or you hear people who say, certifications are better than the degree because you can get them a lot quicker and they're cheaper. Or then you hear people like, I didn't do either one. I was self-taught. And, I just think it's a nice discussion to talk about the more traditional route. We're going to talk about, college versus certs versus self-taught, and we're going to talk about some other stuff as well. I've got some questions about assembly and stuff that we can discuss as well. So I wanted to get first your opinion on how you feel about the whole thing. Do you have any certifications as well as your degree, or are you just strictly college?
The most certifications I have are the trainings that you get at Black Hat, or I've gone to DakotaCon. So,
okay.
Since I was hosted so, I did some of those trainings, but, my reverse engineering is self-taught. So, I know where you're coming from on some of that.
Very cool.
So,
okay.
Yeah, I just have the PhD. That's it. Sorry.
Oh,
not cool.
Wow. Okay. Just the PhD. So, you're also the instructor for classes at the University of Nebraska at Kearney. Are you the Cornhuskers, or you guys have your own?
We are the Lopers.
The Lopers,
not the Cornhuskers. No.
Okay, right on. Is that the other Nebraska college? That Nebraska?
Well, there's 3 different universities. So University of Nebraska at Lincoln, which is Huskers, UNK for Kearney, and then UNO in Omaha has one. And then there's the Medical Center, which is sort of a separate one. But
okay. All right. So, could you give us a little idea of what you're teaching the students right now in your classes, and how it changed over the past few years?
Yeah. So when we go and teach students, we make the assumption that they come in with absolutely zero programming background. So they've never touched a compiler. They've never done any programming. At most, we assume that they have, some math background, so they can do algebra. So that's the extent of what they're required to know. And so from that point, we go and teach them all of the skills, like what is a language, what is object-oriented, what are databases. We teach them about different algorithms, how do you sort things, how do you make an efficient algorithm, what's a bad algorithm. We teach them about automata and what are things that you can solve with a computer program versus, things that are not solvable with a computer program. We have, some more practical classes like software engineering. So they learn, some of design patterns, learn how to use Git or some other repository system. And then we have at the end, they have sort of a practical project that they do with somebody in industry. So they design a website or design an application that solves some sort of problem for that client that they have. And so they have to work through the issues of technology doesn't work, or, the client changes their mind and changes the specifications. So they kind of get a little bit, that's a 1 semester class that they get at the end.
Okay. Do they have any opportunity to learn project management experience or to get involved with understanding the software development lifecycle?
Yeah, so they do a little bit. So, that's probably one of the things that we don't do a lot of, just because of all the content that we need to provide to them. So we have so much stuff that we try and cram in if they're a comprehensive major, they have 60 hours, which you take that divided by 3, right? That's like 20 classes total that we have to go from somebody who can't program to somebody who you would want to hire. So, that's one of the things that we don't do a lot of is, they have that 1 semester class. Some places like K-State, they have a 2 semester long class that they do for undergraduates that they can do in project management. But, that becomes a hard thing to, how do you grade a 2 semester class where some people will come in and, drop the class in the middle. So you have uneven projects. And so it just becomes kind of a real pain to try and do that for that.
So Matt, I get some people that say, I hired this guy right out of college and they don't colleges don't teach anything practical. I mean, the guy day one didn't even know how to use Q radar, and he couldn't even run Monkey Fist to automate a cross-site request forgery attack. I mean, come on. Aren't these degrees supposed to teach these kids the skills necessary to do the job? And, you know, I just want to shake them a little bit because it is computer science, right? And I think the key word there is science. I mean, what's your take?
Well, I think that people that hire kids out of college have to understand what they're getting. They're getting somebody who knows the process of going through college, right? College, you have to go to class. You have to turn in stuff to get your grades. You have to come for 4 years, right? I mean, there's certain things you have to do. And
commitments.
Yeah, and our job is to teach them how to learn. We aren't going to teach them every single skill that they're going to need to know. And if you understand that when you hire somebody out of college, then you can hopefully teach them the skills that they want. Now, maybe it's their fault for not hiring somebody who has other interests and that they just go out and learn things on their own. You know, I have a lot of students that don't do that, but they're very trainable if you say, okay, I'm going to give you a project, you're going to work on it, you know, and they have the drive to go out and do that. And so sometimes I think it's just, you know, they want the guy that has, you know, 10 years experience, but they only want to pay for the guy that's coming out of college.
Yeah. So how long have you been teaching courses at UNK there?
So this is my first year at UNK, and I had 3 years at Dakota State. Okay.
So you've done more than a handful of classes. My question here is, can you look at people in your class and go, okay, these people have the mentality of a programmer, or no, this person is, you know, they're probably not going to get through the class because they're thinking either too literally or they're not thinking, you know, literal enough. Or, I mean, is there a specific, I hate to say stereotype, but is there a specific mindset to have for a programmer?
Well, you can, there's some kids you can tell that it's not for them, right? I've taught the intro class several times, and you can tell that there are a lot of kids that this is not the thing for them, which is why in general, right, we have about 20% of the students after the first class will decide that computer science is not the right thing for you. So you have that sort of set, but then, you know, there's a lot of students where I can tell that they're going to be really good students. You can tell that they really get it, and there's others that will just sort of surprise you. So they may not do real well starting off, but then they find something that they really like. They get into computer science and they really enjoy it. So, but you're right. There are definitely students where you can say, I can tell that guy's going to nail it out of the park. You know, you give them a concept and they pick it up right away. And so you can tell a lot of times.
Mm-hmm. Okay.
Is there something to this? Millennials are much more lazy than, say, Gen X or you know, some of the other generations. Do you see that?
Well, gosh, I mean, if you're going to ask me that, I might say the opposite. I mean, some of these students that we're getting in, and I guess I might be considered a millennial. I don't know, born in 1980. I don't know what generation that puts me in, but there's so many students that they'll just try way different things, whereas some faculty are ingrained in, you know, what they know, and they don't go outside that and say, you know, why don't we use Git? Well, we never thought about that, right? We use CBS. Yeah. Well, CBS is more than a few years old, and Git has some better qualities. So, you know, I taught software engineering, so I said, hey, let's do Git. And they were fine with it, but to think outside we've been doing this for 15 years mentality sometimes, you know, takes a little bit. So, I mean, I don't necessarily buy into that. If I get programmers, you know, they're good, right? We can get really good programmers. It's just, you know, we don't necessarily get as many as I'd like right now. So trying to create our cybersecurity program sort of help with that.
Right on. So you're teaching Java now. Before we did the podcast, you were mentioning that it used to be you guys were used to teaching Pascal or Pascal anyway.
Pascal, yeah.
Pascal, not Pascal. What was the impetus for changing, other than nobody uses Pascal anymore? Was there a reason for you to move to Java? Was it just ease of use? I mean, even when I went through my bachelor's in information technology, we did a class on Java because you got your Java for Dummies books and you go. But I mean, was there any reason? Was there anything driving that?
Well, there are a lot of, for as much as people bash on Java, right? There's a lot of good things about Java. So Java handles the biggest pain in the butt that you have in any language, and that's memory management. So Java takes care of that for you, and so you can go and build things a lot faster without having to worry, did I free that pointer or not all the time? Do I have a memory leak because my program, I didn't take care of that? And Java has there's a lot of code base for it. So there's a lot of Java out there. And in itself, Java is really not that bad. Now, when you stick that web browser plugin thing, right, you end up with a lot of security issues which is where, the main ones come. But, you don't have to worry about memory management, and you can write your Java code once and you can deploy it on all of your main platforms. So Windows, Linux, and OS X, it all runs fine on. And so, those are some benefits of it. I prefer strongly typed languages like Java as opposed to Python, which, has types, but you don't declare them. So, that's my preference. But
so tell me about this cybersecurity program. How is that going to benefit graduates? As far as the difference between that and computer science, the way I see it is somebody with a computer science degree could do cybersecurity if they choose that route. Why specialize in cybersecurity? Why not give them a more well-rounded education?
Well, I think it actually is a more well-rounded education, because what we're doing is we're taking our computer science, so we have a comprehensive, which is 60 hours, but then we have a applied computer science. So we're taking that and adding into it the core networking classes that we have a networking degree. And so you put those two together, right? And that's the real impetus of cyber, right? Is that you have some sort of program that's connected to an internet connection. So you might say that one of the biggest downfalls of our computer science, or one of the things they don't have, is networking background. Right? We don't force them to take any real amount of networking, right? They might learn about sockets, but other than that, they don't have that understanding of what are all switches and routers and some of those things that you would get in a networking course. So I think that's the benefit that we're adding by creating a cybersecurity degree.
Now, the cybersecurity degree, is at a bachelor's level or is that a master's level, or?
It's a bachelor's level. So it's 63 hours, I think. So it's a comprehensive, which means you don't have to have a minor in our terms. So
I see.
Mm-hmm.
So
that was my next question. Is it sort of like a minor? You've got a computer science degree, but you're minoring in security.
Well, it's its own degree. So we added, we did add the reverse engineering course. So that's the course that I created and I teach. So that's going to be the capstone for the cybersecurity students. So, to understand reverse engineering, if you make a nice networked program, right, you have to understand both computer science. How does assembly work? How does a compiler work? And you got to understand networking. If I give you a PCAP, then you need to reverse engineer and figure out, what that program did inside of it using that PCAP. So you can take those two worlds and sort of combine them together. And, we're teaching them the basics. And when they get onto the real job, right, that's when they have to actually learn, at company XYZ, this is what we need from you.
Now, there's a chart you posted in the show notes, annual jobs available versus bachelor's degrees granted. And they have like mathematical sciences. It looks like 4 times as many degrees than jobs. And I know there can be some intermixing between them. Like you can hire somebody to be in IT that has a math degree and stuff like that. But social sciences, I can't even fathom. Maybe 10,000 get degrees and 300,000 degrees versus 10,000 jobs.
Yep.
That's amazing. And then the only one that is in favor of the graduate is computer science.
Yep. And that's why, you have companies starting up degrees that are, quasi computer science. We have a company here in town called Expansion that does software testing. And so they're taking kids that have a high school degree and training them in software testing because they can't find enough computer scientists to do the jobs that they need to get done. So that's what we end up with right now is you're springing up all kinds of training that can help people to at least get into that job field.
Yeah, like the technical degrees or the community colleges teaching computer related skills to sort of make up for that, right?
Yeah, and that's where we were talking about self-taught. That's where somebody can totally get into computer science and can be self-taught, and they don't need to go to a university. They don't need to actually attend if they are dedicated to going out and finding resources. So I put a couple links in there about, you can go to iTunes U and OpenCourseWare. Sites like Stack Overflow can help you. So there's a lot of resources out there, especially for computer science, because, it's all on the internet. So, that's why people can sit there and easily be self-taught and try and get in. Now, it might be hard to get in the door, but once you get in, right, it really doesn't matter what degree you have after you've gotten hired at most places.
Yeah, I think a lot of people when they tell their kid to go to college, they're going to get a good job after they get out of college. I never expected my college degree to actually get me anything other than a door to open, and thankfully I was already working, so I didn't have a lot of college debt to deal with. But I think a lot of kids who go into various, whether it be the life sciences or social sciences, they go into college thinking that once they get out, they're going to have a, $100,000 job every year. And in which case, a lot of people need to, I think they need to level with their kids and go, okay, you're going to have to pay your dues before you're making $100,000 a year. You're going to have to be in 10, 12, 15 years maybe for some of these, before you get there. Not necessarily with computer science, but with other degree type programs. But I just think there's a lot of people expecting more out of college than what they're actually going to get.
I don't think they do any research to figure out how much are you going to make a year with a social work degree.
Yeah, exactly.
If you ask somebody, social work they might know, but a lot of other degrees, I don't think they have any idea when they start what the degree, what salaries they're going to get starting off. Yep. Now we tell our students, we say, yeah, you can expect $55K a year in the middle of Nebraska.
Mm. Do you guys do any kind of job placement or anything like that when they get out of college? Is there any kind of guarantee for that?
We do not have any trouble getting our students hired. 99% of them. What we say is every student that gets a degree in computer science that wants a job will get a job. And that's true. If they want to get a job, they can get a job. Now, some of them, don't. They get out, they get done, and, they don't want to do anything. But a majority of them who get out get a job. Because
they have ideally they have the technical skill to at least get, to speak intelligently at an interview.
Yeah. And we have employers all the time saying we need to have, all of my juniors, most of my sophomores have a job already that they're working part-time where they're going to school. And all of my seniors have a job.
So they're doing like internships or something?
Yeah, some of them will do internships. Some of them are just working part-time at some of the tech companies that are in town. So yeah, it's not a problem with getting them hired.
Now, are they we talked before the podcast, you had companies that would come in and tell you guys, we'd love to hire these people, but you've got to, we really need Java developers, or we really need X. And do you guys worry that by only teaching Java or only by teaching certain thing, just because companies are telling you to do that you're hamstringing the developers from learning, say, C or something?
Well, it is an issue that, it's a good issue to have, I guess, is that you have enough demand that they say, hey, it'd be really great if you taught Git, right? Okay, well, we can do Git. I mean, that's not a big deal. They like that having Java and having the experience in one language. But, I think that you guys are probably aware that once you learn one language, right, the other ones are really easy to learn. There are some hard concepts in C and assembly, which thankfully I teach them assembly. So, we get those concepts, and we are modifying our curriculum so that we're adding more. We're going to add, C or C++ in the sophomore level classes, so that they get exposed to that memory management and those issues that are related to that. But yeah, it can be an issue. At K-State, we had Python for a while, and the instructors and some of the employers complained that they really wanted to have kids that had 3 years of Java. So, the department chair made the choice to switch back to Java, and you can gripe about it or not, but it's just what it is. So
sure.
Do you think it's less of a risk for a company to hire someone with a degree, or versus certification or self-taught?
Less of a risk.
Well,
so if I had a choice between these two potential hires, one has a degree, one doesn't. They both seem to have similar skills. If you think someone with a degree would be less of a risk?
Yeah, I think in general, just because of the commitment that they put in.
See, that's what I've always heard. Yeah.
You got to go to school for 4 years. And if you look at the difference in all sort of the teachers at a university, there are all kinds of styles of how they teach a class. Do they require attendance? Do they have tests? And so being able to understand how to please a teacher enough to get a passing grade is a skill that you really can't sort of measure in somebody who's self-taught. Now, again, you said equal skills, right? A lot of times you can have somebody who's self-taught that has really great skills.
Right.
And, that's the person you should probably hire. But that's why you do interviews, right? That's why you don't just, throw a resume down and say who has the best resume gets hired. So.
Well, I think self-taught, you also have to have some work experience. So, you're not going to graduate high school and then, normally you're not going to graduate high school and drop right into a developer role. You have to have either, a GitHub repo that's showing what you're doing, or you have to show some kind of body of work that shows that you know what you're talking about.
Yeah. And a lot of times it's, you go to a company. So the company that I worked at, Onyx, right? They still accepted faxes, right?
Wow.
Because that's what people in the middle of, guys that do, put in bathrooms, they still use faxes, right? So I think if there are certain jobs where you can get in and have no experience, be a millennial, right? And be the tech person. Sure. And so I think, there are those jobs that you can get in with relatively low experience and, like you said, go and learn figure out the ropes, build that sort of background so that you can get a better job. And I've seen people that have done that.
Very cool. So do you recommend to your students to code on the side or code not just when they're in class to, embrace it? Because obviously, this would be a practice makes perfect kind of thing. Other than the homework, do you recommend they get involved with open source projects or anything like that? Or are you worried about them picking up bad habits from outside the college?
Oh, I would encourage them to code, but I don't really need to. The ones that care, they go out and code. It's actually a problem for me because they go and I can't find anybody hardly to do research because all of my students have real jobs.
Yeah. Yeah.
So, I can encourage them, but they see the money out there and they just go start working. So it's not really a real issue that we have to deal with. I can find some, but I got to start early. I can't wait till they're juniors.
Yeah, no, completely understand. Well, it's good that they've got that drive, So after they've taken your class, you're not teaching just the intro class, right? You're teaching other classes at the school there, and you said you were working on the cybersecurity degree. Mm-hmm. Do you suggest to them that they take the CS stuff first and then go to the cybersecurity, or can you do them both concurrently?
Yeah, so hopefully we'll be offering it fall of 2017, but they'll take them concurrently. So we'll probably have a lot of interest. Kind of the way that it worked at Dakota State was we had a lot of kids that came in and said, cyber looks cool, I want to do that. And then when it got to the programming, right, a lot of them said, I can't do that. So they would switch to a more sysadmin type of degree at that point. And so, it'll basically be sort of self-selecting where the kids that have the aptitude to do it will go on and do it. And they'll do both networking and the CS in parallel until you get to that, the ultimate class, which is the reverse engineering, where they have to use sort of both sets of skills in that type of class.
Yeah. So are you seeing any kids in your classes that have, like here in my school district here with my daughter, some of the after school programs show or teach programming concepts, or like, what do they call it? Swift? Is it Swift or something like, whatever the new Apple programming is, or they do robotics or something where they're learning programming concepts before they even get up into high school or college. Do you ever see any of the kids that have said, oh yeah, I did this in high school, or, I was in part of an AP kind of advanced course where I was learning this already?
Yeah, we do see some of those students, but it's the students that had a teacher that decided they wanted to teach it, because at a lot of states, including Nebraska, it doesn't count for a particular credit that they can get a CS class. So you have to have somebody who wants to do it. So you have to have a teacher that wants to do it or a volunteer that wants to do it. Otherwise, schools are, since we have the No Child Left Behind, they're driven by the standards that are issued to them. So they have to meet their standards, and computer science doesn't match a standard, so we don't have to teach it.
Yeah.
Now, some states, I hear Arkansas, which has Walmart, it has CS that will count towards your high school degree. And there's a handful of states that do that. And so, that's something that, if we had more kids that at least explored it, then hopefully we would have more students that are interested in it when they get to high school, which is what we really need. It's not that, we can take them if they have an interest in computer science and we can turn them into computer scientists, but you got to have more students that think of computer science as a degree and something that they want to do.
Yeah.
Now, Matt, I'm looking at the, it's by topuniversities.com, the list of the top computer science programs. You've got MIT, Stanford, Oxford, Carnegie Mellon, all the top computer science departments in the world. what do you think separates them? I mean, why are they considered the best?
Well, some of it is history, right? So you've got some of those that have had computer science programs for a very long time. You look at places like Kearney, we haven't had, a CS degree for as long as some of those big places. But, if you're looking at that, you're probably looking at some university that has a really good research oriented system. And my opinion is that when you get to that point, you don't care as much about your undergrads as you care about your grads. And that's just because, what drives them is research dollars.
Yeah.
And so the people who are going to do that research are going to be your grad students, right? You might get an undergraduate that you'll get 1 good year out of, but a graduate student, you'll get 2, 4, like me, 8 years of, good research. And that's their thing, right? They want grad students, and they have an undergraduate degree as well. And they have really good teachers, but they don't, their teaching load is going to be 1 class or 2 classes. And so their primary job is to do research.
Now, I think that there's a theory that a lot of these top schools have such restrictive, I guess, or such high admission requirements that no matter what they teach these students, they're going to be successful anyway. It's kind of like a self-fulfilling prophecy, right?
Yeah.
Because these guys are so good just to get here, it doesn't matter what we teach them. They're going to be a success later on, regardless.
Yeah, and that's a good point. I think that there's also, if you aren't one of those students, right, if you're not getting a 36 on your ACT, right, you have to work a little bit harder than that guy that gets a 36, right, because everything comes naturally. And, some employers prefer to have a student that comes out of, some small university like UNK versus some big one, because you're going to have some student who's going to work really hard, and they're not going to be this brilliant person that's not going to be able to work with people. I mean, at the end of the day, you still got to work with people, right? For almost all your jobs, you got to work with somebody.
All the jobs with dogs and cats are taken, so.
Yeah.
Well, it's also name recognition. If you're going to go to Harvard or Oxford or something, one, you got to be fairly well off. And, employers are going to look at, oh, he went to, Harvard or he went to Oxford to get his computer science degree. I don't know why Harvard would have computer science, but, if you're going for an employer who's looking for name recognition, then, it's like, buying a $3,000, suit versus a $350 suit. There's, the amount of, time and effort it went to make the $3,000 suit versus the one that made $350 suit. I mean, at some point you're not going to really tell the difference. You're going to get the same kind of coverage on the suit. One just may be a little shinier than the other. And, I would argue that going to UNK is going to make you better off financially, because you won't be spending $300,000 for a degree that, arguably you're probably going to get as good, or, you're going to get just as good at a smaller college than you would a Harvard college or an Oxford or an MIT.
Yeah, I'd agree with that. I think that students that get, I really think that for most universities, somebody who gets a computer science degree, right, would be somebody I would hire. I wouldn't really care if they were from Oxford or from, UNL or UNK or any of those.
Mm-hmm. So, one thing I wanted to discuss, you are teaching, or you did teach the CSIT course, the 301 course, which I was talking to you late last week about, coming on the podcast and whatever, and you sent me the the link to your videos where
Mm-hmm.
you're teaching assembly to these kids, and you've got the patience of a saint, because I'm listening to some of these videos, and it's like, you're trying to drag that mule, and he doesn't want to go with you. But so assembly, I'm gonna discuss assembly, because one of the questions I was asking, because I didn't understand some of the programs when I'm doing my OSCP, which is a certificate. But I was reading some of the machine code, and I didn't quite understand what MOVAL-1H is or anything like that. And your videos were very, very well done. I gotta pick your brain about how you did them, for screencasting purposes. But what made you guys teach the assembly course? Because obviously Java and assembly, they're not really kind of the same. So
Yeah, so at Dakota State, they wanted to redo the reverse engineering course. And I said, well, I can do that. So I went and did that. And when I got in there, I found that my students really didn't have the assembly background that they needed. And so I also taught assembly. And so the impetus for teaching assembly was that to build up enough skills so that by the time they get to reverse engineering, they understand what, opcodes and mnemonics are, and what are all the registers on a 32-bit machine. And so when I came here to UNK, I taught reverse engineering last semester. And again, they just didn't have the skills that you need when you go into a reverse engineering type of course. Mm-hmm. And so the reason why I went back years ago, they taught assembly, and then they said nobody uses assembly. So they said, okay, we're going to make our computer organization class about memory and interrupts and things like that. And I came in and said, well, I think they actually probably need that. And the jobs that are related to that are going to be reverse engineering, understanding, why is it that I get a Stack Overflow when I call my recursive function too many times? Well, you have to look at it at the assembly level to sort of understand that. And I think it really opens up the eyes of those students who have only really done a lot of things in Java, right? All of a sudden, they see what happens when they take a program and they turn it into a binary, and how does it actually work on the back end, and what are interrupts, and it just kind of opens their eyes to some of this type of issues that we really don't have to deal with in general. But when you look at security and you're looking at an exploit or some other some shell code, right? How do you understand what that's doing? And that's why we put it together. And so I've taught it enough times that I understand a lot of the issues, which is why you can tell that I'm pulling them forward, because I know the things that they're going to get hung up on, because I've taught it enough. So
sure. Yeah. No, I love those. I've done some war games before where it was like, oh, you can, look at this binary, and, it's not something that's easily readable. It's not like where you can go in and go, okay, this if statement or whatever. That assembly was just, it was like reading Greek to me. So a lot of your videos were, I've only gotten up to about 10 on the 30 so videos, but it's definitely helped me out a lot. I've understood them. And it was easy to understand. They're about half an hour a piece. Was that the whole class, like a half an hour for the class?
Yeah, I mean, I do a few things at the beginning. So it's a 50-minute class, but I take attendance and, do a few things while I'm getting ready. So, but I when dealing with students, I found that if a video is 20 to 30 minutes, they're more likely to pay attention than if it's 40 or 50. Mm-hmm. Okay. So at the end, right, you can talk all you want, and they just don't listen.
Yeah. Yeah. I mean, you were explaining, the two's complement. You were explaining Indianness to the point where I actually understood the Indianness of it. Various, how to convert everything over and add one. And if you're trying to learn assembly, I would definitely, the link will be in the show notes, but it was definitely an excellent course that I'm still going through. So plus I can count it as CPE. So that's always a good thing for my CISP. Yeah.
Yeah. See, I was going to do, the way I earned my DerbyCon ticket is I was going to do assembly and reverse engineering at Derby, but
Oh, that's awesome.
they
Yeah.
they didn't want to do it. So
Oh, really?
well.
That's
That's a
shame.
bummer.
Did you try it as a track talk or a stable talk?
I did it as a training. So
Oh, right. Okay.
Yeah.
Yeah. The other thing I like about it is the assembly class you're teaching, the book is free.
yeah,
So the drpaulcarter.com and what's the difference between NASM and MASM?
so NASM just runs on Linux.
Okay.
NASM runs on Linux, OS 10, and Windows, but MASM only runs on Windows.
Oh, right. Okay. So M is being Microsoft in this case.
Yep.
Okay.
Microsoft Assembly.
Okay, right on. So go ahead, Mr.
Under self-taught, right? We talked about the motivations and all that, but what are some of the bad habits people can have if they don't have like a structured training or degree?
Yeah, so some of them that I've seen is that, when somebody learns something and they see that they can solve a problem with it, that all of a sudden they see every nail, right, they can hit with that hammer. And so, a good example is, so I used to listen to a podcast by Joel Spolsky and is it Jeff Atwood? And there was like this moment where Jeff is not trained typical computer science, and he's trying to do parenthesis matching, and he's trying to write a regular expression to do it. Mm-hmm. And Joel just is trying to explain to him up and down that you can't do it. You can't match every single set of parentheses. No matter how many you pick, you can't do it with a regular expression.
Yeah.
And it was that point of he knew how to do a regular expression, but he didn't understand the limitations of what a regular expression could do. And that's the biggest thing that students will learn is they just, if you're self-taught, you don't get those sort of little insights that I can't solve this problem with this thing. I need to use something else. And that's the big thing that you miss is those little nuggets that sometimes, somebody who's taught this, who's programmed, can just see and say, no, that's bad. You shouldn't do that. Here's a better way. Mm-hmm. And so I think that's the biggest thing that people who are self-taught miss.
Well, there's a glut of free training out there. I mean, there's what's iTunes U? I've never seen that. That's the Stanford thing where they were I think one of the first courses they taught was cryptography. I think that was the first course they had.
Oh, they have a lot. There's a lot of. It was built into iTunes, and I used iTunes years ago, so that was kind of the universities on iTunes.
Yeah. Okay. Yeah, there's a ton of them. There's OpenCourseWare. There's Cybery. Cybery does one. Mm-hmm. When I was attempting to work on my Python skills when I was learning Python, Pen Tester Academy was another good one. So that one costs a little money though to use, but yeah, self-taught isn't always necessarily free, but it is cheaper than certifications, and it's probably more cheaper than college. So.
Yep.
Yeah. So
I use Stack Overflow quite a bit, but you have to understand its limitations. I mean, you could copy and paste from Stack Overflow and just introduce like a command injection into your code. So you gotta be careful.
Yeah, you got to be able to read code. I think if you're just going to copy paste, I think you should at least understand the code you're copying and pasting before you actually use it.
Well, yeah, you have to, but just make sure you go over that code real carefully.
Right.
Yeah.
Okay.
Yeah, I've contributed on Stack Overflow for a while. So.
Oh yeah. A couple days after we did this interview with Matt, he emailed the podcast and asked us to remove the section about Tor. The reason being that the litigation is still ongoing, and he wasn't sure if any of the information he had mentioned was under any kind of, sequester or anything like that. So just to make sure that nothing bad happened to him, we decided to remove the whole interview in the event something did happen. We will have him on later on after all the smoke is cleared with this lawsuit and, ask him his thoughts.
Yeah.
Awesome. Okay. Well, so if anybody wanted to talk to you about assembly or, whether or not they should go for a degree or if they should, come to UNK and hang out or, what you're doing for DerbyCon, how would they get a hold of you? What would be the best way to do that?
Most people email me, so that tends to work. My email is millermj@unk.edu.
Okay. You ain't got the Twitters or the Face Spaces or anything?
I do, but I don't have those all memorized. I tweet some stuff.
Well, we're gonna tweet you up, so it'll be good to
I'll put them in the show notes for you.
Sweet. Yeah, definitely hit up the Twitter because you'll get some followers on Twitter. I don't like to brag, but we're kind of a force of nature. We kind of do that. So, Mr. Betcher, how would people get a hold of you with your fancy CS degree over there?
Yeah, number 22 on the list. Sorry.
Easy, easy.
@BetcherPwned would be my Twitter handle.
All right. So mine, I'm just, simple bachelor's of IT over here. I didn't, I had to work my way through college, but, the Navy paid for it, so that was cool. So, hey, you know what? That is definitely an option for anybody who can't go to college. I graduated high school. I had a 1.1 GPA. I had to take a night class to be able to graduate high school. So the Navy was definitely a good place to get an education. They paid for some college. So you can find me at Brian Brake. I got better. I learned. I persevered. So I got better. The official BrakeSec podcast is at BrakeSec, BRAKESEC. We have a Patreon. We believe in the value for value model. So if you want to, support us over there, you can give as little as $1. If you want to, if you got a lot of good out of this, or any of our other podcasts, if you found a value in any of those, we're on Tumblr. We're on, various internet radio sites, TuneIn, Player.fm. We're on the Google Play Store, iTunes. Please feel free to leave feedback on iTunes if you want to. So, any last words, gentlemen? I'll start with Matt over there, Dr. Miller.
Yeah, apparently I'm Millhouse30 on Twitter.
Millhouse30, right on. Consider yourself followed.
Is that a Seinfeld? Not a Seinfeld, a Simpsons reference.
It is. It is a Simpsons reference.
Steven.
I got the nickname when I was in 6th grade.
Yeah, you need to work on that. You only have like 3 follow and 1 follower, so you need to work on that.
I know.
Millhouse30.
Yeah.
Okay.
With no E.
With no E. Okay, so that makes a difference because I'm sure there's more people. So, all right, cool. Well, yeah, if we always like having people on. So if you want to come back and talk about things, I know we're going to try to see what we can do about the tour thing, and come on back, and we enjoyed having you on.
All right, thanks, guys.
Cool. All right, Mr. Betcher, you have a great rest of your week, and I know it's probably a week late, but patch your Symantec, please, because apparently it's gone crazy. So that was it for Breaking Down Security this week. Have a great week, and we'll talk to you soon.
Bye-bye.
Bye.